Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss all the four problem asked in today's LeetCode Weekly Contest 470. So let's start with the first problem. It says you are given an integer array nums. Now the alternating sum of this nums array is the value obtained by adding elements at even indices and subtracting the elements at odd indices, right? So it means that you have to add all the numbers that is present at the even indices, right? So 0, 2 and 3, and similarly you have to subtract all the numbers that is present at the odd indices such as 1, 3 and 5 and so on, right? And at the end we have to return the answer. So yeah, this is a pretty implementation problem, so let's directly jump over to the code. So here is the code. So this is your nums array. This is the size of the nums array and this is my current answer. Now what I'm doing, I'm going through each of the numbers that is present in the nums array. I'm just checking if my current indices is even or odd. If the current indices I is even, and you can check it by taking modulo with 2. If that is 0, it means that the indices is even. So just add it to your answer, right? Answer plus equals to nums of I. Otherwise, if the indices is odd, so you have to subtract it. So answer minus equals to nums of I, right? And that's it. You're then just written the answer. Yeah. Yeah. So this is all about the first problem. Now let's look at the second problem. In the second problem, you are given an integer array nums and you have to return the length of longest subsequence whose bitwise XOR is non-zero, right? And if there is no subsequence exist, you have to return 0. So for example, in this first test case 1, 2 and 3, the longest subsequent that has a non-zero XOR is 2, 3, right? So because if you take a XOR of all the numbers 1, 2 and 3, it is 0. So the maximum length cannot be 3. So it has to be 2, right? For 2 and 3, like you can take it. I think you can also take 1 and 2. So if you take 1 and 2, also the bitwise XOR is non-zero. So yeah, the answer for this is 2. And similarly here, the bitwise XOR of all three numbers is non-zero. So just take it, right? So yeah, this is a good problem. Let's see how we can approach it. In the second problem, we are given nums array, right? And we have to find out the longest subsequent that has a non-zero XOR value, right? So first step, find the XOR of all the numbers, right? Find XOR of all the numbers from 0 to n minus 1. So if that is not equals to 0, it means that we can take this uh, whole array as a subsequence, right? And that is the maximum possible length, which is n. So in that situation, your answer is n itself, because that is the maximum possible length of any subsequence, right? So first check if XOR of all the numbers is non-zero. So if that is true, just return an answer. Otherwise, since the XOR of all the numbers are not is not equals to 0, it means that we cannot take all the numbers, right? In that situation, we have to remove few numbers. So for the second step, check how many number of zeros in there. So if the number of zeros is equals to n. So if all the numbers are 0, so let's say there is a case when all the numbers are 0. In that situation, even though you remove any of the numbers, uh, your jar is still going to be 0, right? So in that situation, so return 0, because in the problem statement it says that if there is no possible subsequence, then just return 0. Otherwise, I claim that your answer is always n minus 1. I'll tell you why. In that situation, your answer is always going to be n minus 1. The reason is, if I come to step number 3, it means that step 1 and 2 both have failed. Failed means the jar of all number is equals to 0 and the total number of 0 is not equals to n. It means that there will definitely a number exist in this nums array that is a non-zero number. Then only your total number of 0 is not equals to n. It means that there exists a number that is non-zero, right? So let's say that number is x, right? What I will do, I will take all the numbers from the nums array excluding this number, right? Then what will be my XOR? My XOR of that remaining n minus 1 number is going to be x. The reason is, I know that my total XOR is 0 and that excluded number is x, and to make the total XOR 0, the jar of the remaining n minus 1 number has to be x, then only your x jar x equals to 0, right? So this is my excluded number. So the jar of our remaining number is a non-zero number, and I know that x is greater than 0. So that essentially does our job. Our job was to find longest subsequence that has a uh, non-zero jar value, right? So if the maximum length n is not possible, so the next max possible length is n minus 1, and that essentially is which we are getting here, right? So in that situation your answer is n minus 1. So yeah, this is all about the explanation part. Let's look at the code now. Here is the code of second problem. So this is my nums array. This is my size. This is jar. So this jar will be the jar of all the numbers, and this is the number of zeros, right? So I'm going through each of the numbers from this nums array. I'm taking the jar and I'm incrementing the number of zeros, right? So then I checked if the jar of all the numbers is not equals to 0. In that situation, just take whole array as a subsequence, right? So just return n. Otherwise, check how many number of zeros. If the total number of zeros is n, means that the whole array contains zeros. In that situation, there is no possibility to take a subsequence that has a non-zero jar value, right? So in that situation, return 0, otherwise return n minus 1. Please check out the explanation part. So there I have explained how this n minus 1 comes into picture, right? So yeah, this is all about the second problem. Now let's look at the third problem. In the third problem, you were given a string s that consists of open and close brackets and an integer k. Now, a string is k balanced if it contains exactly k consecutive open brackets followed by k consecutive close bracket, right? So, for example, k equals to 3, your k balanced string would look like 3 consecutive open brackets and then 3 consecutive close brackets, right? For k equals to 3. Now it says you must repeatedly remove all non-overlapping k-balance substring from S and then join the remaining parts and continue this process until no such k-balance substring exists. And ultimately you have to return the final string after all possible removals, right? So yeah, for example here if you see, when you come to here, you notice that there is a k balanced substring, right? For k equals to 1. So just remove it, and once you remove it, you are left with again a substring that contains k balanced substring for k equals to 1. So again remove it. So once you remove both, your final answer is a empty string, right? And similarly here, this is your k balance substring. So for k equals to 1, just remove it, then you left with two open brackets and you cannot do anything better, so just return that. And similarly here for k equals to 3, if you notice here, this is the k balance substring, so just remove it, and then you are left with these strings, right? So yeah, this is a good problem. Let's see how we can approach it. Before solving third problem, I would highly recommend to solve this problem. This problem is called valid parenthesis, right? Because today's problem is a bit harder version of this problem. So yeah, if you haven't solved this problem before, please check it out, right? So yeah, now let's get back to our original third problem. So we know that we are given some sort of a string that consists of open and close brackets, right? And something like that. And you are also given a k number, integer k, and we have to remove all k balanced strings from the original string, right? So if you notice here, so at the time when you would encounter a k balanced string, it would look like k open brackets and then k close brackets, right? K close brackets, right? So when you iterate through each of the characters in the given string, so one information that is necessary is how many close parentheses, like contiguous close parentheses, you are encountering. For example, here 0 0 0 0 0, here 1, then 2, then 3, then 4. So I'll create a variable that essentially count the number of consecutive close parentheses till current index, right? So here 1, then 2, 3, 4. So the reason is, so let's say that that count is uh, current. So let's say the name of that variable is current. So current will tell you how many number of close brackets you encountered till the current index, right? So the reason was why I am using this variable is that as soon as this current become k, it means that now you encountered k continuous close brackets. It means that there might be a possibility that you are currently facing a k balanced uh, string, right? Because I know that for a like the definition of k balanced string is that you would be having k open brackets and then k close brackets. And since my current is k, it means that I already encountered k close bracket. So what is our next job? Our next job is to check, are we having k open brackets before here? If that is true, just remove it, remove all, right? So that is why you need this variable. And there is one more variable you would required, that would be kind of maybe balance, or let's say that is value. So the value would be this value plus equals to 1 if the current bracket is an open bracket. Otherwise I will remove it, minus equals to 1 if the bracket is closed. The reason is, I know that for a k balanced substring, its total sum is going to be 0, right? Because I know that there would be k open brackets and then k close bracket. So for k open brackets, plus 1, plus 1, plus 1, and so on. And for k close bracket, it would be minus 1, minus 1, minus 1, right? Minus 1, minus 1, minus 1, minus 1. So the total sum is going to be 0. So how do I check if my current so see, as I mentioned before, if my current is k, it means that I encountered k contiguous close brackets. So how do I check if the previous of it has k open brackets? I know that so let's say the total value till here is something value, right? I know that the total sum of this is going to be 0, because I know that for open brackets I'll be having plus 1, for close bracket I'll be having minus 1. So let's say here the value is val. I claim that if this is k, this is again k, at the index 2k minus 1, so let's say this is my current index I, at the index of the value at index I minus 2k, at index I minus 2k, can I say um, I minus this is I minus 1, I minus 2, I minus 2k, can I say the value, if the value at index I minus 2k is again value, what it means? It means that this string is a k balanced string. That's a really I mean that's the whole soul of this problem. If my current is k, it means that I encountered k close brackets now, and so whatever value you have at this at this index, right, at this index, I will just check what is the value at index I minus 2k. If the value at I minus 2k is again k, sorry, again the same val, it means that the sum of this is 0. Then, right, because here is value, then value plus 0 is value. It means that this is 0. I know that my current is k. It means that I encountered k close bracket. So the contribution of this part would be minus k. It means that if the total, the sum is 0, it means that the contribution of this has to be k, then only it is 0. And if the contribution is k, it means that all are open brackets, and that's it. So it means that we encountered a k balanced substring, so just remove it, and that's it. And just follow the same process again and again, right? So yeah, I hope you understand this problem. Like if you have any difficulty, please write a comment. I'll resolve it, right? So let's look at the code now. Here is the code. As I mentioned, this is my string s and this is my integer k. this is my length and this is my current. So current will essentially tell you how many number of closed brackets you have at current index, right? And this is my val. So val is will essentially contains the sum of the numbers. So for open brackets it will be +1, and for close bracket it would be -1. So the contribution is -1, right? So, and this is my tuple. So what I have done, I have stored three information: what is my current bracket, what is my current value, and what is my current this current value, right? So if it is a open bracket, so just your value is going to be +1. So value plus plus, because for open brackets I know that the contribution is +1, so increment the value. Your current is 0 because your current will essentially contains the number of closed bracket, but with for open bracket, so current is 0 and just insert it into the vector, right? Now otherwise, if it's a close parenthesis, what is my contribution? My contribution is -1. Fine. My current plus plus, the reason is current will tell you the number of closed brackets you have till here, and then insert it into the vector, right? But the next job is to check if the current is k, it means that you encountered k consecutive closed brackets, right? So just check, maybe it might be possible that so even though you encountered k closed brackets, the previous of it may have k open brackets or may not. So when it will be having k open brackets, these two conditions will definitely be satisfied. The first condition, let's say the length of total vector is currently m, right? So if m equals to 2k, it means that uh, the total length of the remaining string is 2k, and out of it the last k are k closing brackets. So just check what is my total value. If the total value is 0, it means that the last, so I know that the contribution of last k characters are going to be -k, right? And so if the total value is 0, it means that the contribution of first k character is +k, then only the total becomes 0. And if the contribution is +k, it means that all are open brackets, right? So this is the first condition, if your m is 2k and value is 0, or if m is greater than 2k and the value at index m minus 2k minus 1, right? So right, so my current index is like there is no point of having current index, so I'm finding the index from this m, the size, right? So my current index is definitely m minus 1. So the index before 2k characters is m minus 2k minus 1. Just check the value at there is, if that value is equals to value, and this essentially I have explained in the explanation part. If the value at index 2k minus 1 is same as value, it means that again it contains last k closed parenthesis, and then before it it will be having k open brackets, right? So if either of them is satisfied, it means that you encountered a k balanced substring. So just pop all these 2k characters. So this 2k character consists of k open brackets and then k close brackets, right? So once you remove it, your for let's say your vector is still non-empty. So what is my current value? So just update your current. So current is going to be the current of last character that is present in this vector, and that's it. So once this for loop finishes, just so this is my answer, this is my final remaining string, and just take all the characters that is present in the vector, answer plus equals to the characters, and just return the answer, right? Yeah, that's it about the third problem. Now let's look at the fourth problem. In the fourth problem, you are given an integer n, and you have to count the number of pairs a and b such that both a and b are non-zero integers, and the sum of a and b is exactly equals to n. And a non-zero integer is a positive integer that doesn't contain any digit 0 in its decimal representation, right? And we have to return the number of such pairs, right? So this is essentially a digit DP problem. So yeah, let's see how we can approach it. For the fourth problem, I would like to explain it through the code itself, because this problem is not that much intuitive, and I felt like if I explain it through the code, you would understand it better, right? So yeah, and one more thing, like, so at the end of this tutorial video, you can maybe write this code by yourself, and then you would understand it, all the missing parts, and you would understand it completely, right? So yeah, let's see what I'm doing here. So this is my given integer n, and we know that we have to find two integers a and b such that the sum of both integer is going to be n, right? And they both must not contain any zero in the decimal representation, right? So the first step, what I'm doing here, I'm just finding all the digits that is present in the given integer n. So this is how we do it. While n, just insert the digit into the this vector d. So d would essentially store all the digits of n, right? So one more thing I would like to explain here. So if you notice here, if once I inserted it, I'm not reversing it. It means that let's say your n is something like 5 6 1 2, right? But this d would look like 2 1 6 5 in a reverse order, right? Because I have inserted the last remainder and then second last and so on, right? The thing is, this is my LSB, this is my MSB, right? So, and one more thing, like in the addition, we always do addition from the LSB, right? So that is why my all the calculation would be from LSB, from left, from LSB to MSB, right? And that is why I have not reversed it. So this is my position 0, this is position 1, position 2, position 3, right? So LSB to MSB, that I would like to discuss first. Right? So right, so this is all the digits. Then this is my DP array. So I'll tell you what this DP does exactly, and your answer is going to be 0 0 0 0. So there are four states, right? So so the first one is position, at which position you have, right? Because let's say this n is of something like let's say this is 1 2 3 4 5 6, fifth digit number 6, let's say 5 6 1 3 4 5 4, right? So I know that I have to make like I have to find a pair a and b such that the sum of a and b is going to be this, right? And I will always do addition from LSB to MSB, right? So this position is essentially the current position in the digit, but the thing is in a reverse order, because I know that digit d, this vector d would look like, for this it would look like 4 5 3 1 6 5 in a reverse order, right? So this is my position, this is my first position, second position, third position. So this first argument is this position, second one is what is my current carry, the third one is AZ and BZ. So AZ and BZ, so I'll tell you what this AZ BZ is. So now let's come to the implementation part. So first I check if my position is M. So position is M means I reach to the last index, right? Means that I have exhausted everything. Like you reach to the last index, right? So once you exhausted everything, means that you have found A and B, right? So if you found A and B, your carry should be 0. There shouldn't be any carry, right? So if your carry is 0, then your answer is 1, otherwise your answer is 0. So in one line, just return carry equals to 0. Second case, a standard DP way, just check if you have the answer stored in this DP. If the DP of that pose, position, carry, AZBZ is not equals to -1, just return it. Otherwise, this is my current answer, right? Now what I'm doing here, now this AZBG will come into picture. Now here, this is my LA. So I know that I have to find two integers A, and one integer A and one integer B, right? And this is my position, right? So this LA and RA essentially, if you see here, sorry, LA and RA, yes, LA and RA is the minimum and the maximum value which you can go at this position for A, because see, so this is my position. I know that the digits could be from 0 to n, sorry, 0 to 9, right? But If you see here, let's say to find let's say I have to make the sum of a and b 60, right? So there are two ways. One is let's say 33 and 27, a and b. This is one way when both have like, so both are two digit number. There is one more possibility to get 60. One is 57 and one is 3. So see, for 3 this number would be 0, right? So essentially your digits would vary from 0 to 9, right? But 0 would only present for the leading zeros, right? For the leading zeros, I cannot add any 0 in between, because that will essentially violate the first condition when it says that your none of the digits should be 0. So 0 could be present, but for the leading zeros, right? So yeah, I hope you understand it, right? So here what I'm doing here, this is my LA for, so for A and B, I want to find what is the left and right value, the minimum and the maximum value that can arrive at this position for A, and similarly LB array for B, right? So if my so if AZ is 1, it means that I can take 0 here. So my LA is going to be, sorry, RA is going to be 0. And if my LB is, sorry, if my BZ is 1, so this AZ and BZ could be either 0 and 1. This is a binary numbers, right? So these are binary numbers, and carry is also 0 and 1. Either it would be 1 carry or 2 carry. Sorry, 0 carry or 1 carry, right? So just check if your AZ is 1 or BZ is 1. Your RA or RB is going to be based on AZ. If AZ is 1, your RA is going to be 0, otherwise 9, right? So, and if your current position is 0, it means that your LA and LB cannot be 0, right? Because for position 0, for position equals to 0, your minimum value will going to be 1, right? So yeah, now what I'm doing here, I'm going through the possibilities of from LA to RA for position A, for position in integer A. Similarly for B, I'm just finding the sum. Sum is going to be A plus B plus carry. Just check if your S modulo 10 is equals to, so see, now I know that for this position, A of position plus B of position, this could be either more than 10 or less than 10, right? Greater than equal. If it is less than 10, that is fine. But if it's more than 10, I know that I will, so there will be carry. So let's say that sum is, let's say 12. But here I can put only 2, one would go in the carry part, right? So that's why I have just check if the modulo of 10 is equals to that number present in the uh, n, the given n, right? So D of position, if that is true, your answer is going to be plus equals to, now next position. So now this carry, just check. So if the number is greater than or equal to 10, then the carry is going to be 1, otherwise the carry is going to be 0. So just check if S is greater than or equals to 10. Now for the third position, this is going to be AG, or if your A equals to 0, if your A was 0, then it has to be 1, and similarly for B, if your B was 0, it has to be 1. So just check if BG or B equals to 0. So yeah, I know, I mean, this may feel maybe a bit tough, but I would, but this is not that much hard, I would say. So just try to pause the video and you try to understand this code by yourself. You can get it. And if you have any query, please write in the comment. I'll resolve it, right? So yeah, if you find the video helpful, please like, share, and subscribe to my channel. Thanks for watching. Have a nice day.